Hello, and thanks for joining. I'm Lee House, the CEO of IoT 83. Today, I'll be presenting our perspectives on IoT value creation. Per McKinsey, IoT is set to create between $4 and $11 trillion in economic value by 2025. And this is across multiple vertical markets, including Industry 4.0, cities, medical, retail, construction, heavy industry, industrial processing, and more. And the key use cases they identify are service optimization, operational visibility, optimization, creation of new business models, new service offerings, process improvements, and more. So IoT is well beyond the hype curve and deep into the implementation phase. From our perspective at IoT 83, there's really no question about the value of IoT. The question is really about how do businesses go about capturing this value efficiently and with minimal risks. So the important questions for business leaders become, what concrete use cases will create this value for me? How do I implement these use cases in my operations? And what is my cost and risk to make this happen? These are exactly the questions that we want to look at today. The first thing I think we should emphasize is that the IoT value creation spans across multiple industries. This overall journey is about implementing ubiquitous asset connectivity, asset condition visibility, asset analytics, operations automation, all with a goal to create smarter and more streamlined operations. And the killer applications of IoT, of industrial IoT, and IoT value creation apply broadly across vertical markets. So next, a key realization that we've made at IoT 83 is that there are a lot of IoT design patterns to implement fault detection, prevention, and avoidance, to drive operations efficiency, service efficiency, maintenance efficiency, and asset lifetime management. Once understood, these design patterns can quickly be applied across different businesses. And in fact, we've built templates into our platform and tools to make this more efficient for our customers. So continuing with this overview, it's important to think of assets very broadly. Assets are not just the sensors, machines, or things. Key assets can be databases that provide historical or service data. It could be existing software or middleware that may be important to your overall process or operation. You could have devices that are not well connected but provide important data as logs or files, and these would need to be ingested into a rich solution. Operational data, call center data, field service data, all of this can feed into the creation of a richer and more powerful solutions. So we should really think of assets as everything you own and everything you pay for when you think of implementing a rich IoT solution. Okay, so now let's get down to how this all works. On the left, we're ingesting what is actually happening. We're pulling in asset and sensor telemetry and in the field environmental condition data. We're also pulling in asset configuration data and operational asset settings. All of this tells us what is actually happening. On the right, we've got the asset data set points, thresholds, and triggers to alert on out-of-bound conditions. These can be simple triggers or more complex multivariable analytics or even sophisticated AI algorithms. But even simple implementations will take you a very long way in terms of improving operations. We also have physics and specifications of how devices should run under different conditions. All of this can tell us what should be happening. So the work of the IoT solution is to integrate what is happening with what should be happening to provide us with the tools for optimization. So system-wide dashboards, system drill-down health, about the status of our assets, action on event logic, asset optimization analytics, alarms and alerts, diagnostics, and even prescriptions on what should be done in the case of a potential fault or an actual anomaly or failure. All of this leading to asset uptime, improved asset performance, improved asset lifetime, and improvements in your operational key performance indicators. Okay, so let's look at what impact this has on managing assets. From an asset management perspective, our goal should be long asset life, asset uptime, system-wide asset visibility, analytics, and anomaly detection. What we really want is fault detection, prevention, and avoidance. So if we compare the old way of doing things to the IoT operations path, we see a big change. We see partial performance visibility on our assets to system-wide visibility and drill down into the behavior of specific assets. We have periodic asset configuration to near real-time configuration and maintenance. This can even be automated, and alarms can be created if any device is misconfigured. This can be constantly scanned, and this is just a part of the IoT solution. If the old way, fixed maintenance schedules giving way to condition-driven smart maintenance. Rather than having the potential of running to failure or not doing maintenance often enough so that you might, in fact, run to failure, you see what the behavior and conditions of your assets are, and you can schedule maintenance and asset protection and maximize uptime and protect your assets even further. Going from the old way of limited system view of assets, now you've got a visibility of how the assets operate as a whole. How does one asset operational behavior influence that of another, and how does the overall system operate together? And moving from the old world of spotty performance history to detailed performance and anomaly history, and the ability to create different views of how this all works. Looking at the impact on operations, first, what is our goal? Well, our goal should be to streamline operations, build operational automation, simplify workflows, and build system-wide insights and optimization. So if we look at each of these bubbles in the graphic below, they show different pieces of the solution. It starts with a fleet-wide or system-wide visibility of the overall operation with the ability to drill down on any asset for better understanding of any potential faults or anomalies. Next, we have the ability to create unique actions on events with customized operational control logic. Whether this is simply informing a service agent to go work on a problem or automatically reconfiguring assets to bypass a problem, this flexible operational control logic can do that task. Next, performance analytics on time-based data lets operators see developing trends over time for fault detection, prevention, and avoidance, what we were talking about earlier. All of this then feeds into smart asset configuration rules, smart maintenance and service prioritization, all of this to protect assets and improve operational uptime. And finally, all of this drives work simplification and improvement of our profit and loss overall. Taking this a little deeper and comparing the old way to the new way on operations, we see the old way, manual or human processing of data being transformed to exception-based alarm processing. In these types of operations, there's really no way that humans can efficiently track all of the data that is coming in, and things are going to be missed. With a at-speed processing of an IoT system, this is far more efficient, and really with the amount of data we're talking about these days, basically the only way to get the job done properly. Inspection-driven maintenance, automated condition-based maintenance, we talked about that before, unintended run to failure, leveraging anomaly detection and fault detection, prevention, and avoidance to prevent failures, limited visibility to the total plant, moving to a plant summary of how the whole plant works together with drill-down views of assets. Limited automation potential, very expensive in the old world, to flexible and extensible automation. Difficulty in integrating different applications, moving to open APIs, and it being easy to create new connectors to systems. A key point here is that with the implementation of a modern IoT system, creating new automation, integrating with other tools and software, and building new application workflows becomes much easier because the modern software tools that are available in an IoT system like this. Okay, extending this to the impact on service overall. The reactive in the old way, the more or less reactive service models, moving to proactive and intelligent service models. You react here when there's a problem. Here you react in many cases before the problem has even impacted the asset, because you can see that a problem is trending. We have incremental KPI service gains in the old world. Here, dramatic jumps can be made in terms of service because of the problems can be eliminated before they even occur. So the amount of customer satisfaction that is available here is just dramatically different. In the field problem discovery versus prepared and informed field service actions. In the old world, you go to see what the problem is with the asset that is having problems. In the new world, you already know. You take the right skills with you to the field, you take the right tools with you, or perhaps you avoided the problem completely because you prevented the problem from ever occurring. Service misses, angering customers, becomes fast resolution and customer satisfaction. Excuse me, my slide jumped backwards for some reason. Longer service resolution cycles becomes a proactive, preventive maintenance solution. And finally, risks to assets and warranties moves to an extended operational life. All of this for dramatic improvement to service, which can result in significant P&L gains. So if we sum all of this up, the impact to profit and loss can be huge. With the connectivity to the diverse asset systems, data, and records fed into system-wide drill downs, asset health and condition visibility with telemetry analytics, actions on events, and anomaly detections, finally moving into diagnostics and condition-based prescriptions for service resolution. First-time fix ratios are up, mean time to repair is down, customer uptime improves. We have seen customers enjoy anywhere from 15 to 40% overall P&L gains through implementation of these systems. Okay, this is a really important point to touch on in this, because we're talking about IoT value creation, and we've all heard these rumors. I've heard that many IoT projects fail. Why is that? Well, there's a lot of reasons for this. Having the right skills, the right focus, the wrong partners, unclear goals. But the main reason businesses fail, we believe, is starting from scratch and taking on too much development and risk. A lot of these problems also came from earlier implementations of IoT where it was sort of necessary to start from scratch. The application enablement platforms like what we've built at IoT 83, we're in their infancy. But the IoT 83 built this application enablement platform, Method 83, really with the sole focus of taking this risk away and making it easier and more reliable and lower risk and lower time to market to deliver these kind of P&L impacts. So how do we do this? The IoT, I'm not going to go into this in much detail because we've got a lot of information on this in different webinars. But the IoT application enablement platform is designed to make it very straightforward to implement, deploy, and run the IoT killer applications at scale. On the right, we've got the IoT scalable elastic core. This is the big data processor that has been built to connect has been connected over 50 million devices on a single instance and is used in multiple industrial mission-critical applications. So this core is very well proven, very secure, very reliable, and scalable. Stretching out across the page is the application creation toolchain. Using these tools and workflows enables the industrial teams to independently or working with us to apply their industry know-how to create multiple powerful applications. We had several webinars that go into a lot of depth on how this all works, but the bottom line is the improvements in time to market, reduction in risk, and increase in overall production efficiencies that this application enablement platform drives. Because in the end, this is what you want: a complete workflow that delivers on the promise of IoT value creation and your P&L gains for your business and operations. This is integrated into the platform that we were just showing you. There's a lot of tools and resources to enable these workflows, to be able to carry these, to build these different killer applications and customize them for your particular business so that it applies to your specific key performance indicators and optimizes your P&L. So at the bottom line, this is what IoT is all about. With a goal of implementing the use cases we discussed, business and operators can leverage IoT to make all of this happen. And you can see the results very quickly. Operations efficiencies, service efficiencies, maintenance efficiencies, asset lifetime management, all of these metrics improving, and at the same time reducing engineering costs, development costs, validation costs, and operational costs. So one other point that's worth emphasizing, at IoT 83, we're big fans of driving iterative success. Set some important goals, use the right tools to get the job done, and then deploy for meaningful results. And then do it again for still more business gains, and then do it again. Using an application enablement platform like our IoT 83 platform, you can make all of this happen and make immediate impact to your business. So that's our summary on IoT value creation and the impact that IoT can have on your P&L. I hope that you all found this valuable. And I hope that you'll reach out to us at IoT 83 and let us help you create your IoT value creation breakthrough. We would love to hear from you and help you make this happen. Thank you.